electrovalent and covalent bonding. Electrovalent is also known as ionic bonding. This is between a metal and a non-metal. Example, we have sodium metal and chlorine non-metal. So how do we show this bonding? Sodium is Na and the mass number is 23, atomic number is 11. So when you have 11 atomic number, that means mass number 23, atomic number 11, number of protons 11, number of electrons 11, number of neutrons will be A minus Z is equal to 23 minus 11 is equal to 12. So electronic configuration is KLMN. These are the orbits KLMN. You get 2 in the first orbit, 8 in the second orbit, 1 in the third orbit. So the diagram of sodium is the nucleus has protons 11, neutrons 12, first orbit 2 electrons, second orbit 1, 2, 3, 4, 5, 6, 7 and 8 electrons, and the outermost orbit has 1 electron. So it has 1 extra electron. So if we show the Lewis dot diagram, that will be, and in that we show only the outermost orbit. So we'll show it like this, that sodium has just 1 electron in the outermost orbit. The next case I am going to take is chlorine. So in chlorine Cl, the mass number is 35 and atomic number is 17. So A is mass number 35, Z is 17, number of protons 17, number of electrons 17, number of neutrons 35 minus 17, how many? 18. So here we have the electronic configuration is in the first orbit. See, this is KLMN. First orbit can have maximum 2 electrons, second can have maximum 8 electrons. We are left with 7 more electrons. So if we draw the atomic structure, the number of protons 17, number of neutrons 18, first orbit 2 electrons, second orbit 1, 2, 3, 4, 5, 6, 7 and 8. Third orbit has 7 electrons, 1, 2, 3, 4, 5, 6 and 7. This atomic structure has 1 extra electron. If we remove this, 8 is stable. Here we have 7 electrons. If we add 1 electron, this can be removed. And here it needs 1 electron to become stable. Here it needs 1 more electron to become stable. So if we show the outermost orbit of chlorine, so it will have 1, 2, 3, 4, 5, 6 and 7 electrons. So you need 8 electrons here. This will be transferred to chlorine and it makes a bond which is known as ionic bond, and then it makes NaCl, this compound sodium chloride. So sodium chloride is made by transfer of electrons. transfer of electrons, and this is called ionic bonding or electrovalent bonding. One example I have done here. One more example of ionic bonding. I will take magnesium chloride. Okay, so here we have two elements, magnesium and chlorine. Magnesium is a metal. Metals lose electrons. Okay, and chlorine is a non-metal. Non-metals gain electrons to become stable. They make a compound to become stable, a stable molecule. So if I show magnesium, magnesium is Mg, 24 and 12. 24 is the mass number, 12 is the atomic number. And chlorine is again the same, 35 and 17. So 35 is the mass number, 17 is the atomic number. We deal with only the atomic number for chemical reactions. So the atomic number here, it shows electronic configuration will be like this. I will not give those details which I gave before. We will directly come to the electronic arrangement here, electronic configuration. So 12 we have to divide. Out of 12, 2 will go to the first orbit, 8 will go to the second orbit, and again 2 are left, they will go to the third orbit. So the last orbit has 2 electrons and there should be 8 to become stable. So these 2, if you donate or give or lose, then 8 is the stable number. Similarly, if you see this electronic configuration of chlorine, then K, L, M, N. So here 2 in the first orbit, 8 in the second orbit, according to 2n square formula. I think you know about 2n square formula. So 7 will go to the last orbit, and here if we add one more electron, it will be stable. So it needs one electron to be added. So how do these two combine? So Mg, the valency is 2 plus, chlorine, the valency is 1 minus. These two combine. So how do we show this? We will keep Mg in the middle. Mg in the outermost orbit, it has 2 electrons. I will show them here. According to Lewis dot diagram, I will show them here. That it has 2 electrons in the outermost orbit. On either side of magnesium, we'll take chlorine. Here, one atom here. Chlorine, the outermost orbit I am showing, it has 1, 2, 3, 4, 5, 6 and 7 electrons. Similarly here, 1, 2, 3, 4, 5, 6 and 7 electrons. Now this has 1 less, this has 1 less, this has 2 extra. These will be lost to, donated to chlorine, these electrons, and that makes a bond. So this is how magnesium donates its electrons to chlorine and becomes stable by having 8 in the outermost orbit. And here one chlorine atom will take 1 electron, the other chlorine atom will take another electron from magnesium, and that's how magnesium 2 plus, chlorine 1 minus exchange, and you get Mg1Cl2. 1 we do not write, so the compound is MgCl2, and this is again one example of ionic bonding. Same can be done for zinc chloride, for magnesium oxide, one metal, one non-metal. You can combine any of these and have these kind of combinations for ionic bonding, one metal, one non-metal, right? Thank you. Covalent bonding. Covalent bonding is because of sharing of electrons. Sharing of electrons, this can be done between two elements or atoms of two elements which are non-metals. So non-metals gain electrons. So what they do is they share what they have. So I'll take example of oxygen. Okay, oxygen is, if you write the atomic structure, you draw the atomic structure, oxygen is 16 mass number, 8 is the atomic number. So you have to take care of this number 8. Okay, mass number is 16, atomic number is 8, number of protons 8, number of electrons 8, number of neutrons 16 minus 8 will give you 8, and electronic configuration for electrons. Draw them in the orbits here, KLMN, K, first shell, second shell, third shell, fourth shell. So out of these 8, 2 will go to the first orbit, 6 will go to the second orbit. Now this 6 is not complete. It needs 2 more electrons to become stable. Right? So the valency of oxygen is 2 minus. When you gain electrons, when the atom gains electrons, it gains a negative charge on it because electrons are negatively charged. So when you draw the atomic structure, protons are 8, neutrons are also 8 in this case. First orbit has 2 electrons, second orbit has 1, 2, 3, 4, 5, 6 electrons. So there you need 2 more electrons to make this outermost orbit stable, right? So the Lewis dot diagram will, if you show the last orbit only, you will have 1, 2, 3, 4, 5, 6. So this is the Lewis dot diagram. Here we show the outermost orbit only. So I'll take, there are two in oxygen molecule, there are 2 atoms of oxygen. How do they combine? They share what they have. So I'll make another oxygen atom with the same electronic configuration. It will have the same electronic configuration. There are 1, 2, 3, 4, 5, 6 electrons. So what they do is they share what they have. These electrons will combine and one particular oxygen atom will have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Similarly, this oxygen atom will also have 8 electrons. How? 1, 2, 3, 4, 5, 6, 7, 8. So sharing of electrons is shown by these kind of circles, that one particular atom is having 8 electrons in the outermost orbit. So this is done. I will show you another example of carbon tetrachloride, CCl4. So this is also because of covalent bonding. So you know about chlorine we have already done before. Chlorine is, the electronic configuration is KLMN. So chlorine has 2, 8, 7. So it needs one more. And carbon. Now carbon is 12 and 6. Electronic configuration will be KLM. If we show only the 3 orbits, then the first orbit will have, according to this, it will have 2 in the first orbit, 4 in the second orbit. Now here it can give away 2 or take 4. So this is also in a state of sharing the electrons which it has. So what we do here is we take carbon in the center. It has 4 electrons in the outermost orbit, right? How do we show carbon tetrachloride covalent bonding? So chlorine I'll show here, and we will also show the outermost orbit of chlorine. Now as you know, it has 7 electrons in the outermost orbit. So I'll show with the help of cross here. 1, 2, 3, 4, 5, 6, 7. Again 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. Now this carbon and chlorine will share the electrons like this, like this, like this, like this. This is sharing. We will not show the arrow here. Here they are sharing what they have. Now one chlorine atom is having complete outer octet. This also complete outer octet. This also complete outer octet. And here also complete outer octet. That means every chlorine is having now 8 electrons in the outermost orbit. 1, 2, 3, 4, 5, 6, 7, 8. So this is same for all. And this goes for carbon as well. This carbon atom is also having 8 electrons in the outermost orbit. This had only 4. Now it has 1, 2, 3, 4, 5, 6, 7, 8. So this is how we show the bonding. In case of covalent bonding, we show the circles. We show the outermost orbit which has 8 electrons, and this is how they complete their outer octet and become stable molecules of compounds. So one thing that you need to keep in mind is covalent bonding is sharing of electrons, and electrovalent bonding is transfer of electrons. Electrovalent bonding means transfer of electrons. So a few examples I have done. I hope you have understood. Thank you.